Okay, in 9.6 we're going to be furthering our study with the trigonometric functions. Remember last time we just wrote in the fractions. However, beginning this time we're actually going to be using these equations to find things in the triangle that's missing. Now the first thing that I want to do is convince you that these equations actually really work. And we want to do it with a triangle where we have all of the sides and all of the angles. So let's say this is a 30, 60, 90 degree triangle. And remember, I can figure out exactly what all these sides are because remember the pattern, it's x square roots of 3 and 2x. So if I let this side be 5, this side would be 5 square roots of 3, and then this side would be 10. So we know these are the correct angles and the correct sides for this triangle. So now let's see if these equations actually work. Okay, so the sine of 30 degrees. Remember, sine is supposed to be opposite over hypotenuse. Opposite over hypotenuse. So what's the opposite of 30? The opposite side is 5. So that would be 5 over 10. Okay, which is the hypotenuse over 10. And then so that's equal to 0.5. All right. Now, with the tangent of 60, remember tangent is opposite over adjacent, right? So what's the opposite side for the 60? 5 square roots of 3. And what's the adjacent side is 5. The 5s would cancel and leave you with square root of 3. All right, so here's how I want to convince you that these equations actually work. I want to take it and put sine of 30 and sine of 60 into a calculator and see if we can get these numbers. All right. Now, if you haven't already, I would suggest that you download another calculator because typically the calculator that comes with the phone, it does not have a lot of times the sine and the cosine functions on it, or especially won't have the inverse functions. So the one that I suggest for you guys to download is Desmos because it's got graphing capability and it has all of the trig functions on it and everything. All right. So now, when you go into this, the first thing that you want to do before you start plugging in the trig function is in geometry, we're only going to be looking at the angles in degrees. Now, when you get to pre-calculus, you'll be looking at trigonometry in different types of angle measures. But for geometry, we just look at degrees. So you want to make sure the Desmos calculator is set to degrees by clicking on this little wrench. And down here at the bottom, you'll see radians and degrees. We want to make sure that that's set to degrees. And once that happens, we can go in and we can plug in sine of 30. Now, where do you get sine? It's a function. Remember what we said earlier? So, again, you press function. It's the very first one. Sine. And then we want sine of 30. We had already set it to degrees. And notice what we get. We get 0.5, which is the same thing that we got right here when we did it by hand. All right, so I'm just showing you that these equations work. Sine of 30 degrees is 0.5. Okay, what about the next one though? Let's go with the tangent. So we'll go tangent of 60 degrees. All right, now that's 0.105104. And coach, we got square root of 3. Okay, well, guess what? Square root of 3 is. Oh, I messed up. That wasn't supposed to happen like that. And the reason why I messed up is because I'm supposed to do tangent of 60. All right, not 6. And so now if I do that correctly and then I go back and look at square root of 3, then they match up. All right, so they're the same. So again, these equations actually work. That's the first thing that I wanted you to see. And it works with something that you already know, which is 30, 60, 90. So it does show you that these actually do work. Okay, so like I say, also that Desmos calculator is handy to have because it's got graphing capability. It has all the sine, cosine, the inverses, all that stuff on it. All right, so now how do we actually use these equations to find something that's missing in a triangle like this, for example? Okay, so they've given me one of these angles here, actually two because this is 90. Because remember, to use the trig functions, it has to be a 90-degree triangle. It's got to be a right triangle. If it's not a right triangle, then you can't use these equations. All right? So it's a right triangle. They've given me one angle here is 41. They've given me x, which is what I'm trying to find, and they've given me this as a 32. So based on these measurements, I should be able to find the length of this side with either sine, cosine, or tangent. So the first thing that we want to figure out is which one of these three equations do I use? How do we figure that out? Look at the parts that are being given to you. So start with the reference angle. Look at x. Is x the opposite, the adjacent, or the hypotenuse? And so remember, that's why we practiced this in the last lesson. Remember, opposite is across, so x is not the opposite. X is the adjacent because it's connected to the 41 degree angle. All right, so x is the adjacent, and what's 32? 32 is the hypotenuse. Once you identify what parts you have, then you can go in and pick the right equation that has those parts. They've given me an adjacent and a hypotenuse. So if I have an adjacent and a hypotenuse, what equation am I going to use? Cosine. So write down the cosine equation first. So once you identify it, write it down. So cosine of theta equals to adjacent over hypotenuse. Okay, so once you write it down, fill it in. And once again, why did we pick cosine out of all three of them? Excuse me. Sneeze. All right. So why did I pick cosine out of all three of them? Because I have the adjacent and I have the hypotenuse, right? And which one involves the adjacent and the hypotenuse? Is cosine. All right. So now once I pick the right one, let's plug in the parts. Remember, this is the angle. What's the angle? 41 equals. What's the adjacent side? The adjacent side is x. What's the hypotenuse? 32. All right? So now I have an equation that I can solve for x and come up with the answer. All right? Now, you guys know what x over 32 is. It's just a fraction. But some people now start to become concerned about cosine of 41. Coach, I have no idea what that is. What is cosine of 41? Now, remember what we told you last time. Sine, cosine, and tangent, they are just functions, much like square root is a function. All right? So remember what we said last time? Square root by itself is not a number, but square root of 25 is a number, right? Okay? Much like cosine by itself is not a number, but cosine of 41 is just a decimal number, right? So keep that in mind. This is just a number over here. So now that you understand that, how would you solve an equation like this? Well, I need to isolate the x by itself. So if x is being divided by 32, I need to do the opposite of that. Multiply both sides times 32. Now I will leave this as cosine of 41 for now because now I can just type the whole thing into the calculator one time instead of making it a big decimal right now. Okay, so the 32 will cancel, right? And that'll leave me with x equals. Well, what is x equal to? It's equal to 32 times the cosine of 41. Well, let's see what that's equal to. And I guess I could leave the x on this side if I wanted to. It doesn't really matter. So now, we can go back into our calculator. We'll clear these off. And what am I trying to put in there now? I'm trying to put in 32 times the cosine of 41. All right? And so my answer right here is 24.15. All right, so there is your answer. All right? And once again, it's worth a double check to make sure that you are in degrees. Got to stay in degrees for this. All right? Radians will give you the wrong answer because it's a different unit of measure for the angle. All right? So there you go. Identify, figure out whether you have opposite, adjacent, and hypotenuse. Use that to identify what equation to use. Plug in the parts in the right place. Solve the equation, and then you got it. All right? Let's see. What about this one? Okay, so here I have the reference angle 38. Let's see what parts we have. X is on the opposite side. Okay, 15 is the hypotenuse. Opposite and hypotenuse. What am I using? I'll be using sine. All right. So write the equation down. Sine of the reference angle is equal to opposite over hypotenuse. And sine, now, what is the reference angle? It's 38 degrees. The opposite side is x. The hypotenuse is 15. All right. So I've identified the correct equation and I've plugged the right parts into the right place. What do I need to do? Multiply both sides times 15 That'll cancel out, leave me with x equals, which is what I want. What's x equal to? 15 times the sine of 38. Let's see what it is. 15 times the sine of 38. And then there it is, 9.23 is the correct answer. All right. Okay, so up to this point, both of the examples that we used, the x ended up in the denominator, or excuse me, in the numerator of the fraction. Let's look and see what happens if x ends up somewhere else, how we would solve it. Like in this one, 64, I've got 18, which is the opposite side. I've got x, which is the adjacent side. Opposite and adjacent. Okay, across is opposite. Connected to it here is adjacent. Opposite and adjacent, what would I pick? Tangent. Opposite and adjacent is tangent. So I have tangent of the angle is equal to opposite over adjacent. And then so now I'll go in and I'll plug the right ones into the right place. So this will be tangent of 64. Opposite side here is 18. The adjacent side here is x. So now notice this time the x ends up into the denominator or the bottom of the fraction. It ends up in the bottom of the fraction. And so once that happens, then what I will need to do now is I will need to see, okay, how can I get x out of the denominator of the fraction? How do I get x out of the denominator of the fraction? Well, I need to multiply both sides by x. Okay, so that will get the x out of the denominator of the fraction. And so what that will then leave me with on this side is x times the tangent of 64 is equal to 18. Now I'm still not done because I need to isolate the x. I need to get the x by itself. All right? So in order for that to happen, what's happening to x? It's being multiplied by the tangent of 64. Well, remember, that's just some decimal number, right? So if I wanted to get x by itself, I needed to make that number cancel. So in other words, if this was x times 5, I would divide both sides by 5. But since it's x times the tangent of 64, I need to divide both sides by the tangent of 64. Because remember, that's just a regular number, decimal number is all it is. We don't know what it is yet, and we don't need to because we're going to plug everything into the calculator. That will cancel and leave me with x equals. Now we can come to this side and see what the x equals. It's 18 divided by the tangent of 64. Let's see what that is. That is going to be, we need a fraction. It's going to be 18 divided by, go to my function again, tangent 64. All right, and then we've got it. It's 8.78. 8.78. All right, 8.78 is the correct answer there. All right. Now, as you're doing these, you can make sure that you can take a look at the answers and see if it's in the ballpark or makes sense. Because remember, the hypotenuse is going to be the longest side. The short side should be shorter than the short leg is across from the smallest angle. So if this is 64, then this would be like 36 degrees. So this should be smaller than 18, and it is. So if I got an answer of 24.66, then I would know it would have to be wrong because this is the shorter side. It's got to be less than 18. And neither one of these can be bigger than the hypotenuse. So those are some little cues that you can look at just to say, okay, does my answer at least make sense? All right. Okay, we got several more that we want to take a look at here. So on this one, we've got adjacent and we got the hypotenuse. Adjacent and hypotenuse would be cosine. So I've got cosine of the angle is equal to adjacent over hypotenuse. Let's go ahead and plug in now. Cosine of 42 equals to, the adjacent side is going to be 8 and the hypotenuse is going to be x. So x ends up in the denominator once again. All right, ends up in the denominator. And so when that happens, we'll multiply both sides times x. So that leaves me with x times the cosine of 42. X will cancel there, equal to 8. We're ready to divide both sides by the cosine of 42. Cosine of 42. And so that'll cancel out and leave me with x equals, which is, of course, what I want to figure out. And we can run back over here now to the calculator. We'll clear that off. This time I want 8 divided by the cosine of 42. And so we got it, 10.77. That is the length of the side, 10.77. All right. So we've done 2 examples where x is in the numerator. We've done 2 examples where x ends up in the denominator. There's one more place where x can drop. All right. And we'll look at that now with these next couple of examples. So again, x is my reference angle this time. 8 is the opposite. 12 is the hypotenuse. Opposite and hypotenuse, I'm going to be using sine. So it'll be sine of the angle is equal to opposite over hypotenuse. We're ready to drop these in now. And so this time the angle is x. So now x is my angle. We'll talk about that in a minute. Opposite is 8. Hypotenuse is 12. So the sine of x equals to 8 over 12. So this is what we've got to think about. This time x is wrapped up inside of the sine function. It's wrapped up inside of the sine function. So you're taking the sine of x. Now, if you're doing something with a regular arithmetic, you do the opposite, right? Okay, so like if this was 2 times x, we would divide by 2 to get x by itself. If it was x plus 4, we would subtract 4 to both sides to get x by itself. So you always do the opposite of whatever's happening to x. So the question is, what is going to be the opposite of the sine function? Okay, so remember the function I always try to relate these trig functions to is square root. Well, what we need to find is the inverse function to sine. All right, and so the inverse function to square root is squared because they undo each other. Square root and squared, right? They're opposites. So what I need to find is I need to find the inverse function for sine. What's the function that undoes sine? So like, for example, if I take the square root of 25, that's equal to 5, right? But then if I turn around and square it, I'm back to the number I started with, 25. So I need to find the function that undoes sine so I can get back to the number that I started with, which is x. And it turns out that the function that's the opposite of the sine function is called inverse sine. And here's what it looks like when you write it out. It looks like sine to the -1 power, but that -1 right there is the symbol for inverse. It's called inverse sine. All right. So what we need to do actually is do the inverse sine to both sides. So I'll do inverse sine of x equals to the inverse sine of 8 over 12. Okay? So remember, inverse sine and sine are opposite of each other's. So really the inverse sine of the sine of x is just x because they're opposites, and then the x just kind of falls out of there, right? And if we wanted to verify that that was true, look at this. Now when I go here, notice that second column, those are all your inverse functions. So if I do the inverse sine of the sine of 15, well, guess what that answer is? It's 15. Okay? Because inverse sine undoes what sine did, and then you're back to 15. So the sine of 15 is some decimal number. The inverse sine of that decimal number takes you back to 15. So if the inverse sine of the sine of 15 is 15, then the inverse sine of the sine of x is just x. They undo each other. And then so what do I need to do here now? I need to find the inverse sine of 8 over 12. And it's 41.81. So that degree measure is 41.81 degrees. 41.81 degrees is the answer there. All right? 41.81 degrees is what we've got as an answer. Okay? Let me see here. What else do we got? Let's try another one, same type. So here's my reference angle. I have the opposite right here. I have the adjacent here. Opposite and adjacent. We'll be using tangent. So tangent of the reference angle is equal to opposite 5 over the adjacent 18. And so once again, I was supposed to actually write the equation down first before I plugged it in. Opposite over adjacent. And remember, that helps you keep everything straight as you plug in. It helps you memorize the equation. That's why I typically like to do that first. Now I can start plugging in things. The angle is x, the opposite is 5, and the adjacent is now 18. All right? So again, I've got x wrapped up inside the tangent function. So what do I need to do to both sides? I need to do the inverse tangent to both sides. All right? Inverse tangent to both sides. All right. The inverse tangent of the tangent of x is just x. So now let's see what the inverse tangent of 5 over 18 is. So now I need the inverse tangent of 5 over 18, and that happens to be 15.52. So we'll go 15.52 as our answer there. All right, so we're in good shape with that. Let me see here. One other problem that you might be faced with that you don't really need to be overly concerned about is one like this. They could ask you to find both of the other missing sides, or two things in the same problem. Find x and y. Well, in a problem like that, all you will just do is set up one equation to find x, and you'll set up one equation to find y. Just do two separate equations. You can come up with the answers. So don't let this throw you off or scare you if you come up with a problem where they ask you for x and y in the same problem. Okay, so let's start with x. Let's find x first. Okay, and so when we're looking at x here, then what we can say is that my x is here. Here's my reference angle as 52. Now, there are two different ways that you can go about setting this up, because if this is 52, I can find this angle as well, right? Because remember, all three of these need to add up to 180. And so if this is 52, then this one's got to be 38, because 52 plus 38 plus 90 add up to 180. So now that I know both of these angles, I could really use either one in order to come up with the correct answer here, right? So I could use 38 as my reference angle, or I could use 52 as my reference angle. I could use either one. It doesn't matter which one that we use. And so on this one, let's just think about what would be easiest to set up here if I wanted the x. Let me see here. So I could go opposite and adjacent. I could use tangent if I wanted to with the setup there. So we could go tangent of the angle equals to opposite over adjacent. So tangent of, let's say we use 38 as our reference angle. Then what we would have is the opposite over the adjacent, so that'll be x over 15. Then all I would need to do is multiply both sides times 15 times 15. X cancel, or the 15 cancel, leave me with x equal. Let's go 15 times the tangent of 38. So we'll go 15 times function tangent 38, and that's 11.72. All right, so for the next one, for y now, it doesn't really matter which one that we use. We can use 38 or we could use 52, either one. Let's stick with 38. So we'll go cosine of the angle equals adjacent over hypotenuse, because if I'm using this now as a 38, 15 is the adjacent, y is the hypotenuse. Adjacent and hypotenuse is cosine. Now I can plug in the right parts. Cosine of 38 degrees is equal to 15 over y. So y is what I'm solving for now, so I need to multiply both sides times y to get y out of the denominator. And then we've got y times the cosine of 38 equals to 15. Ready to divide both sides by the cosine of 38. And so y is now going to be equal to, let's see, 15 divided by the cosine of 38. And then so that's 19.04. 19.04. All right, so again, look at the parts that you have, identify whether you have opposite, adjacent, or hypotenuse, use that to pick the right equation, and then plug in the right equation and then solve for your x, and then you'll be in good shape. All right, there you go.